Venn diagrams. Pictorial representation of sets complements its subsets, its intersections, and union of sets by means of diagrams, and those diagrams are called Venn diagrams. It's real. Some learners are visual learners. They learn better when they can see things in not in abstract way, rather real, or with the help of diagrams. So we are going to revise all those concepts which we have learned before in terms of Venn diagram, and we start with universal set. For universal set, we are always going to draw a rectangle. Like universal set will always be represented by a rectangle, and of course all the other subsets under consideration, all the other sets are the subsets of that universal set, so they all will be contained in that rectangle. For example, here we have a set U, which is a universal set. U represents universal set, and these are students of entire class. And set A, which of course is a subset of the universal set, represents 4 students: Anne, Jacob, Sarah, and Tom, which are students of Mrs. Glosser. And if you take a look on this rectangle on the left hand side, the universal set is represented by this rectangle, and set A, which is a subset of U, is represented by a circle within that rectangle. And now if we want to find out a complement, if we want to find out A complement is equal to what? A complement is universal set minus A. Like all the elements of universal set will be included in the complement of A, minus you will take away the elements of A. So these will be here. If we want to list them here, this is being represented by the yellow part. The yellow part is representing the complement of A. And of course, which students belong to that area? Lindsay. Lindsay is in universal set, but that is outside A. And same is Sherry. Sherry is not in A, she is in A complement. Danny. Danny is not in A, so that belongs to a complement. And David. David. And then the last is Thomas. Thomas. If we were to write elements of A, then Anne, Jacob, and Sarah, they will be represented inside A by different dots. So that's what A complement is with the help of Venn diagrams. Now let's take a look on the same question, but let's take a look on figure number 2. Here we have set A and B. Now obviously there are some students which belong to A and they belong to B. So which students are common to A and B? So those students are represented by A intersection B, and A intersection B will be equal to what? That will be Okay, here. A intersection B consists of which students? Sarah and Tom, because Sarah is here and Sarah is here. Sarah is common to both of them. And Tom is here and Tom is here. So these are the only two students which are common to both A and B, and therefore we have A intersection B will be equal to Sarah and Tom. In tabular form, yes, Sarah and Tom, we have written down a set, but this, with the help of Venn diagram, which portion of the figure 2 will represent A intersection B? Clearly, the black overlapping area between A and B, that is this area is A intersection B. And if you were to represent Sarah and Tom by dots, or if you wanted to write their names should be written only in this black area, because that black area represents the area which is common to both A and B. But what about the red area of A? Of course, that area will be representing all those elements of A which are not in A intersection B. So the red area will represent, let's take a look. So red area will be equal to all those elements of A which are not common with B. So which students will be written in this area? Clearly, Anne and Jacob. These are two students which are in A, but they are not in B. So we will name it as A minus A intersection B, because A intersection B represents the common area, right? So A minus A intersection B will represent the area of A which is not common with B. So obviously, if we wanted to write a mathematical name for this red area, we are going to write A minus B. We can write it as A minus B, or we can also write it as A minus A intersection B. But A intersection, because from the difference of sets, that's how we write A minus B. That is also same thing. A minus B or A minus A intersection B. Let's take a look on few more. This time we are going to draw a picture ourselves here. This is a universal set, and let's say that this is A, this set is B. Of course, they have some common area, which is of course known as A intersection B. what is this area? If I was to, this area would be called what? This area would be called B minus A. And this area of A, which I am representing by slanting lines, this area will be called as what? A minus B. And this area is called B minus A. This is called A minus B. Now if we take a look on this figure number 3, now we have three sets, A, B and C. And I have named some of the area, or rather all of the areas with their corresponding names. A is a set, B is a set, and they have some common area. Similarly, there is another set C, which has some area which is common to both B and C. Now, O represents what? The area which is labeled as O, that is equal to what? That is an area which is common to all three sets A, B and C. So this will be called what? A intersection B intersection C. Because O, which is white area, that belongs to all three sets. Now the area O and X, that is area which is only common to A and B. So O and X combined, that is called A intersection B. And area represented by O and Z. O and Z is equal to what? That is B intersection C. And Y and O, that is definitely an area which is common between A and C. So that is A intersection C. So a question for everybody is that how will you label the blue area? So blue area will be labeled as, now question is that the green area is represented by what mathematical expression, and pink area is represented by what mathematical expression in terms of sets, and blue area is represented by what mathematical expression, and then yellow area is represented by what mathematical expression. And this is okay, well, let's answer these three questions. The green area is obviously this area, this part of C. So green area is represented by C minus this will be C minus C intersection B union, okay, let's C minus B union C intersection A. This is, if we take if we take a look at the distributive law which we learned in previous lesson, the C intersection and C intersection is common in both. So technically we should be able to write C intersection B union A. That's if we make use of that distributive property of intersection over union. So similarly, if we try to look at pink area, that will be B minus B intersection A union C. And blue area will be represented by A minus A intersection B union C. And yellow area is represented by what? Yellow area is represented by, that's B intersection C. B intersection C, which is of course area common between B and C, but we have to take away O, which is a portion which is common with A, so B intersection C minus A. So this is how we can label different parts of the Venn diagram. If we take a look at another example, which is here, and I'm going to drag it down to the next screen here. Okay, here we have three sets like before, A, B and C, and we are trying to establish this identity actually with the help of Venn diagrams, that A minus B intersection C is in fact equal to A minus B union A minus C. So here, if you take a look, we will prove this. If you take a look that when the minus is operating from outside, the intersection is converted into union. It's just like that distributive property. A minus will operate with B, it will operate with C, but in this case the intersection will convert into union here. But let's prove this. In this example, if you look at this figure, the leftmost figure, in this leftmost part we have grayed out only A, and then there is a negative sign here, and in the second part, which is right here, the grayed area is actually the area which is common between B and C, and that's why this area is labeled as B intersection C. Now, if we take a look on the first part and second part, and from A in part 1, if we take away that area from A which is common between B and C, then what is left behind? The left behind is this moon-like area in part number 3. And now on the right hand side of your identity which you want to prove, what is A minus B? Means take away the area of A which is common with B. So this is the area we are talking about. And then in the fifth part, if we take a look at the grayed out area, this is the area of A which is not common with C. And if we combine both areas, grayed out areas in part 4 and part 5, that definitely gives us the exactly similar area which is in part number 3. That's how we can establish this identity. But there are other ways to prove this, but this is with the help of Venn diagrams. In fact, we can prove all those laws, the De Morgan laws, and all the other laws which were A intersection B complement is equal to A complement union B complement, A union B whole complement is equal to A complement intersection B complement. That's it for now, and I will see you in the next video.